All right, so let's continue our discussion on linear inequalities in one variable. So for this next example, we have 6x minus 12 is greater than 8x plus 2. So we got to remember the rules will be similar to how we solve equations. We check if there's anything that we need to distribute. Next is we combine like terms. So in this case, 6x minus 12 is greater than 8x plus 2. We want our variables to be typically on the left side. So we can transfer positive 8x. So we will subtract 8x here. So this is going to be 0 minus 8x. And so now the left side will have 6x minus 8x, which is negative 2x, minus 12 is greater than positive 2. Now we want minus 12 to be on the right side. So we are going to add 12 on this part. So this is going to be 0, and we add 12 over here. And so now our inequality is going to look like negative 2x is greater than 2 and 12. That's going to give us 14. And to isolate x, we need to divide by negative 2. Divide both sides by negative 2. So we can see here that we have x. Okay, this is negative. Negative divided by negative is positive 1. 14 divided by negative 2 is negative 7. And remember, because we divided by a negative number, this inequality is going to change sides, or it's going to flip. So our final answer will now be x is less than negative 7. And if you are going to graph it, of course, we have our number line. We have 0. Negative 7 is on the left side of 0. And we are pertaining to the less than value. So we are going to point to the left. And since it's a regular less than, it's going to be a hollow dot and then pointing to the left. All right, moving on. Now, sometimes you will also be seeing some three-part inequality. So just like this one, negative 3 less than 2x plus 1 is less than or equal to 3. So you do not need to worry about it. Let me just copy it first over here, plus 1. All right. So pretty much in solving a three-part inequality, whatever you do in the middle, because that is where your variable is, right? Whatever you do in the middle, you do on each side. So if we want to isolate x, in this case, we want to remove the plus 1 first. So that would be a minus 1 in the middle. So we subtract 1 on both sides. That is the only difference there. We are doing it in two other ways. Okay, so now we will have 2x is just alone in the middle now. This is a less than or equal to. Negative 3 and negative 1 together, that's going to be negative 4. 3 and negative 1 together is going to be 2. Now, as you can see, we need to isolate x by dividing 2 in the middle. So this is going to be 1. We divide 2 over here, and we also divide 2 on this side. So now, our expression is going to be x is right here in the middle. Do we change the orientation of our inequalities? No, those inequalities will remain because what we divided is a positive number. All right, so now we evaluate negative 4 divided by 2 is negative 2. And then 2 divided by 2, that is a positive 1. So this is your inequality. So when you are graphing it, so let's have, this is 0, we have negative 2, and we have positive 1. Now, if you are getting confused on how to graph this, you can split them up into two parts. So this is first part. Now, we are not used to having the variable on the right side. So if you prefer to flip it, so it will be x is greater than, okay, because as you can see, the opening is towards x. And then negative 2. So this one we can easily understand. And with this, we have a hollow dot on 2, and it is going to be pointing to the left, okay? Now, do not put your arrowhead yet because you have a second part of the inequality. And in this case, the second part is this, which is already the easy way to work because this is x is less than or equal to positive 1. So less than or equal to is a solid dot. and it is pointing to the left, and you can see that the 2 points will be connected to each other afterwards. Okay, so let's take a look at this next example. So again, if ever you see a number or a variable right beside a group, always start with distribution. Okay, that will always be the first part. So in this case, this will be 3 times x, which is 3x. 3 times positive 1, which is positive 3, is greater than 3x plus 5. Okay, now if you combine your like terms, okay, you can choose to have the 3x on the left side. So this is going to be a 0, and this is going to be a 3x. Now, as you can see, 3x over here will also get canceled. That's going to be a 0. And now you are down with 3 is greater than 5. Now, is this statement true or false? Okay, is 3 greater than 5? No, this is false. And so if the statement that you get is false, it means there is no solution. All right, so in this case, as you can see, our variable got eliminated, and we are left with a statement that we need to identify if it is true or false. Let's have this next example. So again, do we have something to distribute? Yes. So we have 2 times x, which is 2x. 2 times 5, which is positive 10, is less than or equal to 5x minus 3x plus 14. All right? So always the first step is distribute. What will be the second step? Always remember, second step is combine like terms. So we can combine, on this case, we have something 5x minus 3x. That could be combined to 2x. So that's 14. Nothing to combine on the left side, so that stays as it is. Now we want our x's to be on the left side. So we will be subtracting, let's use a different color. We will be subtracting this 2x here, so minus 2x, so that's a gone now. Minus 2x over here. Now, if you will notice, our variable on the left side will also get eliminated. 2x minus 2x is 0. And we are left with 10 is less than or equal to 14. So now, again, we evaluate the expression. Is 10 less than or equal to 14? True or false? It is true. And so we will have infinitely many solutions on this part, meaning any value could make the inequality true. And so that's everything about linear inequalities. Thank you.